Okay, today we're dealing with ladders and stairways, and hopefully none of them like this. One of the worst combinations is when you have to work over top of a stairway in some way, and then you start using a ladder. So a couple of these in the middle are dealing with that aspect. But none of these pictures are good. Okay, so don't do what these guys are doing. So first of all, I stole this graphic, and it's not spelled right. Ladders should be ladders, but it does illustrate that we have different angles. A ramp has to be a much gentler slope, and then stairways are somewhere in the middle area. Actually, for OSHA, you can go up to 50-degree slope with stairs when you're talking about the stair stringer, and I'll show you an example of that later. But for the building codes, you have to be somewhere in that area of 30 to 35-degree angle. And then for actual ladders, they're supposed to be somewhere around 75 and a half degrees. But they can be vertical if they are what we call fixed ladders that are mounted to the side of the building, mounted to the side of a tank or something. And then there's these danger-prone areas in between where a stairway doesn't work very well, and a ladder certainly doesn't work very well either, for between 50 and 65 degrees for any setting. In a construction zone, you could have a ladder as steep as 50 degrees. A stairway as steep as 50 degrees. But for residential construction, for commercial construction, for a building of any kind occupied by normal civilians, somewhere around the 30-degree angle is where we want it. When you start to have stairways that are gentle enough that you're less than 20 degrees, you start to have a lot of trouble with that also. So there's these certain zones in red here that does illustrate the issue here of different angles. So first of all, ladders, stairways, and scaffolding are all part of how we work at elevation. Here we're focusing on ladders and stairways. They fall under subpart X in the construction standard between 1926-1050 through 1926-1060, and they have an appendix A in there also. Meanwhile, within that same section is also stairways in that same area there. So they're subdivided and they're dealt with together. Whereas scaffolding, which will be our next topic, is in a different section of the construction standards, subpart L, 1926-450 through 454. Okay, well, let's see here. This all comes under the fatal four, the top four ways that people have This all comes from the top four ways that we have fatalities in the construction business. Falls, working from elevation. And so that's the top one. And so dealing with ladders, stairways, and scaffolding kind of relates to that area. Meanwhile, of course, struck-bys and caught-in-betweens we've covered already, and they deal with 10% and 3 or 4% respectively. And then, of course, in between those two is electrocution, which we're going to get to soon. Okay, so working with ladders. Look at this picture. I know I've shown it to you a few times in this course, but this is a stage picture. First of all, nobody could be this foolish all at once, but they're staging the idea of, of course, over on the very right-hand side, you get somebody standing on the top, on the shelf and the top rung up just below the top hinge point. So we actually could call that the second rung he's standing on. That's not good. And then we got another fellow who's standing on a paint sprayer here in the center of the picture, and maybe kind of on that little lean-to area, I guess, it goes down into the basement. And then we got a guy over here by the power line near the left-hand side who's climbing a ladder next to aluminum ladder that conducts electricity right next to a power line, and carrying a paint sprayer as he goes. And finally, the guy on the very right-hand side, he's climbing a ladder that doesn't seem to have enough ladder sticking up. You're supposed to have at least 3 feet sticking up to hang on as you're climbing up to get up on the next level. And you're never supposed to stand any higher than the 4th rung from the top of a step ladder, of an extension ladder or a straight ladder. Meanwhile, up on the top of the deck, you've got three people that are up there working, and two different ladders up there. And actually, technically speaking, you're not supposed to have a ladder, ever use a ladder on top of another platform. So you can't use ladder on top of scaffolding to extend your reach. And this is a platform. Yeah, it's a permanent part of the house. So people would argue that case, maybe one way or the other. But ultimately, OSHA is likely to still cite you for putting a ladder on top of a platform. Okay, so lots of things wrong in here. And there's tripping hazards, hoses everywhere, and all kinds of mess. But, and then look at this fun with ladders here. My goodness, we got over on the right-hand side, somebody went Geronimo and leaned a ladder over to the building next door, to that chimney or whatever that is. And he's not at a 4-to-1 ratio. It's too gentle of a slope, so that means a lot more flexing of ladder and the danger of the whole bottom of that ladder slipping out because he's not on a 4-to-1 ratio. Meanwhile, he's probably got the 4-to-1 ratio next over on the left-hand side of this picture. He literally propped a ladder inside of a bucket of a little loader, front-end loader, little toy loader. And then he cut a perch in the tree to sit another ladder to get up a little higher. So, you know, when you got a can-do attitude, it's amazing what they will accomplish. But this is risking life and limb to try to cut a tree down. It's not worth it. And it's certainly something that OSHA would freak out about. Okay. And so then we've got this fella here. He's standing on the do not stand sticker on the second rung from the top of the ladder. When we consider the hinge point, that black part on that ladder, to be the top rung, you're never supposed to ever stand on the top two rungs of a step ladder. Okay, the most common accidents associated with ladders and stairways and even scaffolding are falls, and then being struck by falling objects, and then electrocution, because if you're using aluminum ladders, they conduct electricity, and so fiberglass is, of course, immensely more safer for you. A wooden ladder could be safe from electrocution if it's dry, but sometimes you can't tell that condition, you know, because the surface of a ladder could be dry. It could be left out in the rain and gotten soaked in rain and still conducting well, and just the surface seems dry. And so it's hard sometimes to determine whether your ladder truly is dry enough to not conduct electricity, unless you know where it's been and you know its history. Heck, in Louisiana, wood in its natural state, not wet, just from the humidity, is going to have more moisture, and that means it's going to conduct more than that same wood in a very dry climate. Okay, so what's wrong with this picture? Well, it's another aluminum ladder next to power lines. So yes, it's also maybe steeper than a 4-to-1 ratio, so it's a little steeper than it should be. And notice the guardrail on that set of stairs is pretty Mickey Mouse, and so it doesn't really give you the room for this. Oh, and then you'd probably have to climb that guardrail just to get on the ladder too. Okay, so it should be made of fiberglass or maybe wood. So it's an unsafe condition for several reasons. A stairway or a ladder. I kind of mentioned this already, but when do you start calling a stairway a ladder or a ladder a stairway here? So let me just toggle to here. Here's a stairway, but I wanted to bring up the next picture, and this is what stairways are supposed to be. They're supposed to be at about a 30-degree angle like this stringer is. So the stringer is the structure that supports the steps that you stand on a ladder, on a stairway. So a stairway is, those steps are called treads or tread boards. And so there's a few things in here to notice. Notice that way over on the right-hand side, we talk about the rise, or actually maybe more correctly, we could call it the total rise, but rise is fine. That's the total height from one finished floor to the next finished floor. And then the run would be the distance that you travel from the foot of those steps over until you step up on your final step that is the finished floor up top. And so that's the total run, or the run. Now we can talk about the unit rise and the unit run. So the height from one step to the next is called the riser, or the riser height, or the unit rise. So you see that kind of, if I put my cursor up here and kind of swirl it around up top, you can kind of see that area. Then meanwhile, the width of each step, the full width of each step, which we call treads, those individual boards are called tread boards. So the tread width, so that would be the unit run. So ultimately, you cannot just in the perfect world, steps should be 7'11", 7-inch rise, 7-inch riser height, and 11-inch run. So 7-inch riser height, 11-inch tread width. That's perfect, except that you also have to have the exact same riser height and tread width all the way up. So you have to keep that consistent. So we have to adjust those. So you can't have 7-inch, 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 and then have 2-inch or 5-inch or 9-inch at the top. You've got to figure this all out before you ever cut out that riser board. Now, you're not going to have to do that in this class, of course, but from a safety standpoint, you need to know when stairs are safe or not, to take them out of service or not. And as a construction manager, you would have to inspect the stairs that are being built on your site, knowing that they would fall under a building inspection. But even from a standpoint of safety, if you're building stairs on a job site, or not you personally necessarily, but somebody else, they're not going to, if there's a job site trailer stairs going up into an office trailer or back into a tool trailer that's up in the air, back of an 18-wheeler style trailer, then you are going to, those steps are probably never being inspected by a building inspector, but they do need to be inspected by somebody involved with safety on your site, because you still get in trouble with OSHA. You can still have lawsuits and injuries or worse on those stairs. So you want to make sure you understand these rules. That's where these are so important. So you see the clearance on stairs, whether they're commercial or an industrial, you got a minimum clearance of 6'8". And so if you put a straight edge on the stairs and measure straight up or straight down with a plumb bob and measure that line, you've got to have 6'8", which is the same as 80 inches, which is also the standard height of a residential door. Some commercial doors will be taller than that, but 6'8" is kind of our standard. And yes, there are some people out there in the world, some especially basketball players, that can be that height or more. I know I've got a brother-in-law who has to bend down on some of these doors, so it's like that. So some people are still cursed with having to watch for chandeliers and doors that are lower than they should be for them. But our standard in the industry is 6'8" or more. And so residential construction for sure at 6'8". Okay, so that's enough about that. But I just wanted to get that terminology in here. So let me go back to the page I was looking at. So that angle of those stairs would be about 30 degrees. IBC, the International Building Code, says 32.5 degrees pretty much max for commercial buildings such. Residential can be a little bit steeper, so you can get up to the 35-degree angle, but it gets a little dicey after that. Meanwhile, ladders, I'll get this straight. Ladders can be steeper. I mean, they have to be steeper. So they are normally in that 4-to-1 ratio, which is basically 75.5 degrees. And then, of course, they could be vertical stairs, and that's a little different thing, and then they could be 90 degrees straight up. So in general, you have to have a stairway or ladder at points of access on your construction site where there's an elevation break of 19 inches or more. And then you have to, if you're in a trench, you always have to have an egress, which is usually a ladder, within 25 feet of you. So that means you could have ladders every 50 feet in a trench, and you'd always be within 25 feet of a ladder. Okay, so that's enough things for this page. And I showed you this beat up picture of stairs, and I don't know why I keep it in here, but I can't tell if they're beating them into just trying to straighten them or if they're tearing them up, but they're in rough shape. And stairs are tripping hazards when they are not even and true and straight and all of that. You can't have any more than at a maximum a 1/4-inch variation in steps, but that's a minimum standard. Really and truly, people will be tripping on stairs if they aren't at least within 1/8 of an inch of the same all the way up. Now, one other thing about this picture is that as you decide you're having steeper stairs, in residential construction, you can get away with, let's say, 7 3/4 inch rise. Now, as you increase the riser height, that will tend to make the tread boards slope downward forward. And so what we have to do, as you increase one, you have to decrease the other. And so if we're going to have a riser height on these stairs of 7 3/4 inches, that makes it a steeper stair. It means in order to keep the stairs level on a stringer like this, you have to decrease the treadboard width. So if you had 11 inch, you'd have to have 10 1/4 inch tread boards. Basically, could be, there's another way of calculating it, could be slightly different, but basically, when you're only making small adjustments like that, you can do one for one. As you increase one, you proportionally decrease the other. So what does that do? That keeps the stairs level, and that's important because it's a little funky if you're climbing up stairs that are sloped forward or backwards. But as you do that, now you've got less stair to stand on. So instead of having 11 inches to put your foot down on, you've only got 10 1/4. So it goes the other way. If you decide you're going to have 4-inch risers, which is the minimum allowed by the building codes, you're going to have very wide tread boards. So you'll notice that if you climb up the state capitol stairs, looks like they're maybe 4-inch risers, if I remember right, something close to that. And they're not so easy to climb. You find many people that are literally climb up on each step and then climb to the next one. They don't, if you're tall, you can do a good step from stair to stair, but you're going to be walking very deliberately. It's not particularly pleasant. They just want lots of room to write all the names of the states on those stairs. Okay, so I digress. But anyway, stairs and ladders. One other difference with stairs and ladders is stairs, you can climb up or down the stairs where you're walking forward, right? You can face the stairs on the way up and you can let your butt face the stairs on the way down. But with a ladder, you got to face the ladder when you're going up and you have to face the ladder when you're going down. So that's a difference in how you use stairs compared to a ladder. Okay, so I'm talking about some fundamental things that are pretty obvious once you start thinking about it. The other thing is on stairs is you have to have something to hang on to. So if you're climbing upstairs where you've got a kind of a guardrail type of system, we call them stair rail system. Whereas handrail, if it's mounted to the wall, we call it a handrail. So that's a difference. I'm not going to be tricking you or worrying about that difference too much, but there is a difference and you should know that. Not everybody in the industry uses that terminology properly, so it doesn't mean you correct your boss when he or she mentions it incorrectly, but there is a difference in the definition here. In either case, these have to be strong enough that you can save your life with it by grabbing a hold of it if you're slipping or tripping on these stairs. So that means that just like the guardrails that we talked about in fall protection, the stair rails or the handrails have to be able to take a 200-pound horizontal force. So that's what this guy's doing. He seems like he's on drugs or he's all crazed, but he's doing a test, I suppose, to push or pull with 200 pounds of force. And they should be able to withstand that the same way a guardrail system normally has to support a horizontal force of 200 pounds pushing or pulling at the top rail, which should be the same thing on the top of a stair rail, handrail system. So, look at this platform. There's no handrails on this sucker, and there should be guardrails at the top too, because this is higher than what you should be going without having guardrails at the top of this platform. Now, I would say that I'm pretty confident that this is a 4x8 sheet of plywood on this frame at the top, so that you had a platform. So it sounds like a pretty good idea, but actually you're supposed to have more platform than that, because you're supposed to be able to allow the door to swing out without wiping anybody off the platform. And this platform is such that you've only got enough for that doorway to kind of swing across that thing. You basically got 4-foot wide doors that are swiping across this thing, and it would wipe anybody off that platform. So if the door was to blow closed and somebody was in that trailer, then they kick open the trailer as they're coming out with some tools or whatever is in here, and you were coming up the stairs, as soon as you stepped on that platform and that door swung out, it would take you off the face of that platform, or could depending on how vigorously he kicked the door open or it blew open or whatever. So no, you have to have it by OSHA standards are minimal, less stringent than the building codes. But the OSHA standard would require at least 20 inches additional platform to stand on than that swing of that door. So if that's a 4-foot platform, 4 foot wide, then you need, that's 48 inches, 58, 68 inches instead. So you need another 20 inches. So that platform itself is too small. The second thing is the slogan that you see on the left-hand side of this page. Let me read it. It says, stairways with 4 or more risers or higher than 30 inches must be equipped with at least one handrail. So going up the stairs, you need something to hang on to. So here I can see just down at the bottom of the wheelbarrow that's covering it up, I can see the first riser height. Okay, I'm going to take my cursor over there. That's the first riser height. The second one is right here. The third one, right parallel to the center of that circle. Fourth one. Okay, the fourth one, there's 2 more steps after that. So even if this platform was at this 4th riser height, you would need a stair rail or handrail to hang on to. So it's already not in compliance there. And we've got another 2 steps, because from here we're going to climb up 1 more step, and then the final step is up onto the platform. So there are actually 1, 2, 3, 4, 5, 6 riser heights here. 5 on the stairs, and then 1 more up onto the platform. And this is normally how risers are connected, so that your last step is off of the stairs. In 98% or something like that of the stair systems are going to work that way. But anyways, then there's other problems in this picture. They've got clutter all over the place to trip on. There's welding bottles that are not strapped up like they should be. One of them's laying in a wheelbarrow, and for that matter, there's some other debris, and it looks like there might be nails poking up in a few places. But anyway, so there's lots of things else. There's other things wrong in this picture, but when we're looking at stairs, that's the critical thing. Okay, so you need to remember that statement that I just mentioned. It was written over on the left side here. It says, stairways with 4 or more risers or higher than 30 inches overall to the platform, whichever comes first, must be equipped with at least 1 handrail. Now, if we went with the perfect world stairs of 7 inches, 7 inches times 4 would be 28 inches. So that means that 7.5-inch risers would meet you at the 30-inch mark. But if you had stairs, because you can have steeper stairs on a job site, you could have 50-degree angle on the slope, and that would probably get you to, my guess is probably, if I start thinking about it, 8. You might only get 3 risers before you reach that if you had steeper stairs. Okay, so let's kind of move on from here. Here we're looking at a wider set of stairs, and they're climbing higher. But just because the stairs are wider doesn't mean you're allowed to get away without having a railing, a handrail or some kind, or stair rail to hang on to. Stairs have to be uniform, like I said. OSHA allows you to go from 30 to 50 degree angles, whereas the building codes only allows you to be somewhere around 30 to 32 degrees, maybe 35 degrees in the residential. But it's not a good idea. If I was building my house right now, I would not ever go with anything steeper than 32 degrees. No more than a 1/4 inch variation in any stairway system. That said, 1/4 inch is not a best practice. 1/8 inch is more like it. Okay, so that's some things. Here's some pan stairs. If I go here, you see what I'm pointing to. That is a pan in the stairs. And so you cannot use these stairs until you've filled those pans full of concrete or something else, possibly, but normally we fill them with concrete. So you can't use them until they're ready. It's not safe. Here we've got stairs with a landing, and then you turn around, you come up some other stairs, and this is normal best practice in stairs. You don't want to run too far upstairs before you have a change of direction and a landing to kind of recuperate from, right? Well, but the building codes and OSHA both allow you to actually go 12 feet high, which is about 20 steps or something like that, along the rise. That's a very long overall rise. So this is far better than that. But if you were, but 12 feet is the maximum that you can go before you have another landing. Whether you change direction or not, you have to have a landing every 12 feet in elevation. You have to have at least 30 inches of landing there to stand on. And the stairs have to be at least 22 inches wide. Well, 22 inches wide is very narrow. And so that would never be allowed in the building codes. The building codes for residential require at least 3 foot wide stairs. So that's 36 inches. But on a job site where it's only for people in the construction site or the industrial site, people are allowed to be in narrower stairs. They're considered more of the athletic. You're not talking about elderly or toddlers and such getting on these stairs. So that's why that changes. Now in this picture, you'll also see another unsafe condition. If you look at that rebar sticking up, which I guess they're going to pour a little concrete wall of some kind, I don't know, that curb or something, that rebar should be capped because people could fall on that and become impaled by it. Shish kebabbed. So this picture is showing you again how you need 20 inches beyond the swing of the door. So if this is a 36-inch wide door, which is pretty common on exterior doors anyways, then that door, as it swings out, that's 36, so you need 46. You need 56 inches coming out on that platform, no matter which way the stairs are going. When you start talking about commercial stairs, they can require a lot more than that, depending on how many people are going to be coming out that door. So doors normally in a building should be swinging out the direction you'd go when you're escaping the building. And so that's where that comes into play. Whereas in residential construction, there are plenty of cases where a door is allowed to swing the other way, only because there's only a few people living in a building like that. But it doesn't mean it's always a good idea. And you can't have anything slippery on the stairs either, because of course you're causing slips, trips and falls and other injuries like that. Okay, now let's move over to ladders. So on the left, you're looking at an extension ladder, which, whether it's an extension ladder or a straight ladder, is designed for climbing up and even leaving the ladder. Whereas on the right-hand side of this page, we've got a step ladder, a wooden one at that, also. But a wooden ladder cannot be used like they're using it here. I mean, I guess you can store a ladder by leaning it up against a wall, but you cannot use that ladder to climb. You have to open it up. Step ladders are never allowed to be used as straight ladders. Now, I mean, I've done so, and even had a case or two in my life where I'm halfway up that ladder, or maybe a little more, when the thing just slips out from underneath you, because step ladders do not generally have pivoting feet that give you traction. They are generally fixed legs or fixed shoes, or whatever you want to call them, on the bottom. If they have rubber traction, they're fixed, so they don't pivot to the contour that you're going to go. So as soon as you get to a certain place, the bottom of that ladder will slip out on you very, very easily. So I would say if you're going to break that rule, you make sure you at least tie that ladder or brace it in a way where it cannot slip out. But in general, step ladders, you're only supposed to enter and leave that ladder by way of the bottom. You're not supposed to use them to climb up to get on scaffolding or up onto the roof. If you got to do that, you have to use a straight ladder or an extension ladder. Okay, so another thing about step ladders is you're never supposed to paint them, because you hide the flaws. And you're not going to see the cracks, and they'll be hidden away from you. You won't see the decay if they've been painted freshly, hiding that and such. A lot of ladders like this one are type 3 ladders, which means they're the weakest of ladders, and so they're not really safe in the first place. A ladder like this, you're only supposed to use the steps that you see basically closer to us here, whereas on the back side of that ladder, there are frameworks that are meant to hold the ladder together, but they're not rungs that you're allowed to step on and climb. But they do make heavy-duty wooden ladders out there. This just isn't one of them. Most of the wooden ladders you're going to find are going to be like this, which really are kind of dangerous to begin with. If I was you, I would try to find another ladder to replace it. You're not supposed to make homemade ladders or homemade scaffolding in general. OSHA does not disallow homemade scaffolding, but homemade scaffolding should be designed and constructed under the supervision of a structural engineer who has signed off on this. And that might not be practical, but there are cases where it comes up. Okay, here's some more fun with ladders. Another ladder in a bucket, or this ladder that was braced up. I may have shown you these pictures before too. And here we've got a ladder that's certainly not on a 4-to-1 ratio. It looks like it's closer to a 45-degree angle, and it's barely on the fascia board, so it could slip off for that matter. But you can see, you might be able to sympathize for why they've done that. They don't want to damage the roofing shingles by leaning it against the roofing edge. Normally with a roof, and best practice is you have a metal drip edge or some kind of a drip edge, and then the roofing underlayment will stick out beyond that a little bit, and then the roofing material will stick out beyond the roofing underlayment. And so when you lean a ladder against it, you can damage those edges if you don't have something to protect that with. And so that's why maybe they did this, but it's also sloped so that it's not a stable ladder. And if you're climbing up to actually get up on that roof, you need at least 3 feet sticking up beyond the roof edge to hang on to. A minimum of 3 feet. And you're not supposed to stand any higher than the 4th rung from the top, and the 4th rung from the top on this ladder is way down there. This is also 1/2 of an extension ladder, so it's probably not really meant to be used by itself anyway. So, the bottom piece has the pivoting feet, so I would say that I can't tell which one that part is on this ladder in this case, because there's not enough for us to see. But and then there's tripping hazards around this thing too. So it's not a stable surface, and it's not at the right slope. Here we're at the right slope. This is definitely on the right slope, and this is called an extension ladder. Let's see, how many rungs? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I would say this is a 24-foot extension ladder because I counted 12 steps. So that means you bought 24 feet of ladder, but it's not 24 feet of a usable ladder, because the minimum overlap on this extension ladder will be 3 feet. So that means this 24-foot extension ladder, fully in its full length, fully extended as far as it can go, with that 3-foot overlap, will only be 21 feet long. So they lie. You buy a 24-foot extension ladder, but it's really only 21 feet long. Ladders in general, and a lot of other things, including stairs and scaffolding, that we design them to be 4 times stronger than they need to be. So that's something that you're supposed to kind of keep in your back pocket as a piece of information, but know that you're never supposed to extend or go beyond the rated capacity. So if a ladder is rated for 300 pounds, it means it can take 1,200 pounds at least before it'll fail. But you're never supposed to exceed the 300 pounds. Here, some more fun with ladders. Here we got a golf cart kind of thing where they got an extra 1.5 to 2 feet of height out of the thing by putting it in the little pickup box that's on the back of this thing. And then it was rolling down the hill, so they had to block it, and they even took a 1x8 and jammed it into the frame and into the foundation of a building down below. And then you got another contraption here on the right-hand side, which is even worse. Okay, well, just fun pictures. So we have this classification of ladders by rated capacity. So the original system was Type 1, heavy duty, 250-pound capacity. Type 2 was 225, and Type 3 was only 200. So from Type 1 to 3, you're going to lighter and lighter duty. Meanwhile, the trouble with that system was when they decided they needed a stronger system for heavier duty ladders, well, Type 1A became into 300 pounds, and then Type 1 AA, 375 for double extra duty, extra heavy duty. So first of all, remember the Roman numeral system is Type 1, 2, and 3, where 1 is the heavier duty ladder and 3 is the worst, or the least heavy duty, the light duty. So that's what I say. On a construction site, you probably shouldn't use anything less than a Type 2 And really, the vast majority of sites, they use type 1 ladders or heavier. Because when you think about it, the average person that you know is going to be needing type 1. And if you've got a carpenter's belt on with tools in it, then that adds to your weight, and you got to talk about that weight as part of this weight too. So I've had times when I've had 50 pounds of stuff in my carpenter's belt. I mean, it's a little heavy, and especially in the Louisiana sun, to be doing that. But in the winter in Canada, it was kind of good to have a little extra weight on you. It kind of helped you work a little harder and stay warm. Okay, well, I digress. But just be aware of this system. Now, in Canada, we use the same system, but you got to be a little contrarian. Instead of calling it type 1, type 2, type 3, it's grade 1, grade 2, grade 3. So if you ever hear that. But here it's going to be type 1, type 2, type 3, or it's type 1A or type 1AA. Now what you're looking at is a straight ladder, not an extension ladder. There's no rung locks for hooking up to another piece, but one half of an extension ladder will look basically like this. Okay, and so you see the rungs that you stand on. Those are the steps. We call them rungs. And the side pieces that hold onto the rungs are called rails. And then you got the safety feet that pivot. So in this picture, you get a better picture of the safety feet on a couple of extension ladders. The left one is aluminum. The right-hand one is fiberglass. And if they're the same duty rating, the fiberglass probably weighs maybe even twice as much. So they're heavier. Fiberglass is heavy stuff compared to aluminum of the same strength. They both have rung locks that are positioned into a way where you're going to get your 3-foot overlap. So that's important. And the other thing I wanted to point out here, whether it's a rope and pulley system to help you raise and lower it to where you need it to be. And the feet, the safety feet on the bottom here, pivot. They actually would pivot back so that there's pointy parts that are at the front, so that when you pivot it back, you can stick them in the ground and they can dig into the dirt or the grass so that you get some good traction there. But if you're on a finished concrete floor, some other kind of a floor, then you would pivot it the other way so that you get the rubber feet that are going to be contoured to the ground so that you get maximum traction. That said, you should really never rely on the safety feet. They are better than nothing, but you really should either tie the ladder or block the ladder up. So you could take a board and some stakes and drive them into the ground right in front of the ladder so that you keep it from slipping out. Or you could tie the ladder at the top or somewhere else to keep it in place, to keep it from slipping out. That's what you do to make a ladder safe. Now, this next picture is showing you the scale. I've talked about the 3-foot overlap that you need on an extension ladder. Well, that's the one you should remember. I've got my pair of red asterisks up there to show you that. But that's true up to 36 feet of ladder. And then after that, up to 48 feet of ladder, you need a 4-foot overlap. So I have a 40-foot ladder at home. That's a big heavy-duty ladder, and it's pretty heavy. And at 40 feet long, that means that the minimum overlap on that thing is 4 feet. So that also means my 40-foot ladder is only, when it's fully extended, it's not 40 feet, it's 36 feet long. And I've never had a 60-foot ladder, but apparently you need a 5-foot overlap on that. But the testable point to remember here, because the vast is the first one, the 3-foot overlap. And the reason for that, and the reason I care about that, is the vast majority of your ladders are going to have that 3-foot overlap. The 32-foot ladders, these ladders come in increments like 16-foot ladder, and then you typically add another 4 feet to them. So then the next length of extension ladder is 20 feet long that you can buy on the market, typically from Werner and other companies like that. So you go from 16 foot to 20 foot to 24 foot to 28 foot to 32 feet. And then the next length is usually 40 feet. But it means that all of those extension ladders, except for the 40-foot ladder, you need a 3-foot overlap. So it's the one I want you to know. Okay, so that said, if you've got in a trench or up on a roof, you need ladders, well, then once you have more than 25, when you have 25 or more people working in an excavation or up on a roof, then you need to double up your egress so that you have double up and have more ladders, or wider ladders, I guess, or you could have built-in stairs like they did here. But your egress has to double up when you have 25 or more employees involved. They shouldn't need to take a number to make an appointment to get out of there in an emergency. So you need to increase your egress so that you have more ability to get out of there in an emergency. So that said, again, you don't paint the ladders. I said that already. When you're looking at this 4-to-1 ratio, sometimes OSHA will list it backwards, and they'll talk about the run first and the rise second, which is crazy. But that's kind of what they're doing in this picture here, 1/4 the length. So when you know you're going up 16 feet, the closest thing to a math question in here is that you should know how far you have to pull the ladder back. So with that 4-to-1 ratio, you know that we're going up every 4 feet, you got to pull the ladder back another foot. Well, we're going up 4 times 4 to get to 16 feet, so that means you're pulling the ladder back 4 feet instead of just 1 foot, right? Well, so if it was 20 feet up, you'd have to pull it back 5 feet. So for every 4 feet you're going up, you pull it back another foot. So in this ladder, let's say, okay, it says it's 20 feet long, and when we lean it up against the building, if you know it's 16 feet, then you can just pull the ladder back your 4 foot and you'll be there. The thing about this is making a right triangle where the ladder is the hypotenuse of the ladder, the long side of a right triangle. So the reality is the length of ladder you need to touch the top is going to be a little bit more than 16 feet there, and you need 3 feet sticking up. So if this is a straight ladder and it's 20 feet long, then yes, you're going to lose something. You're going to lose something. So let's subtract off a foot for that. It may not be a complete foot, but you have to go to the next rung of the ladder, and so you lose 3 feet for the what you have to hang on to, and a little bit more than that. So 20 feet would work to climb to 16, but a 20-foot extension ladder would not work, because a 20-foot extension ladder would only be 17 feet long, and so you'd only barely get to the top of that roof, and you wouldn't have anything to hang on to. So that's the problem with most of the ladders you're going to deal with for this kind of thing, for climbing up onto a roof, climbing up onto a platform, scaffolding, anything. Your ladder has to be 7 feet. An extension ladder needs to be 7 feet longer than the height you're trying to climb to. So let me show you here. On this 20-foot extension ladder, you see in this picture you got to have 3 feet sticking up. You actually have to have, you can't step any higher than the 4th rung from the top. So in this picture, the 4th rung from the top is just below the top of that deck. So you lose at least a half a foot in there, maybe more. In this case, it's more than a half a foot. Actually, it's 0.6 of a foot. So I say you just subtract a foot in every case. That'll work all the way up to 32-foot extension ladder anyways, and more. And then you need 3 feet for the overlap, and you need another 3 feet to hang on to. So that's 7 feet right there, basically. So a 20-foot extension ladder can really only get you up 13 feet in the air. Subtract 7 feet from it, and about 13 feet is about all you can trust to get for height on an extension ladder. So a 20-foot long, you can get you up 13 feet. A 24-foot, subtract 7 from there, and you get 17 feet you can get out of that. A 32-foot extension ladder can only get you up, I think 32 minus 7, can get you up to 25 feet of elevation. So it's in a 7-foot rule is a really good, useful thing for you to use to make sure you show up with the ladder that's the right length. If it's too short on one end, you're going to be tempted to use it anyways and risk life and limb because you didn't do the math. So use that 7-foot rule. So this thing I've got in writing is another thing that I created here many years ago, and then only in, it's like I say, I've been teaching this stuff for a couple of decades now. I've only seen in just a few recent years, and I've taught thousands of people, so I suspect that now that I'm starting to see it in textbooks that it really came from me, but maybe I'm bragging too much. But 3/8 of an inch is what you lose per foot of climb. Every foot that you climb up at a 4-to-1 ratio, you're losing 3/8 of an inch. It's just basic trig. but it's something that there's a couple of things that I've adopted over the years that I then see many years later. And I think it's because of me spreading that tip. But anyways, I digress in bragging here. Okay, so this is an important basic thing, but you need to know these numbers. 3 foot overlap, 3 foot extension above the landing to hang on to so you can climb safely off the ladder onto the next platform. If it's a fixed ladder, it's mounted vertically like this. So then fixed ladders are much harder to climb because, you know, once you're on this ladder, even though you're supposed to have 3-point contact, 2 hands and a foot or 2 feet and a hand, if you stopped and had to flap your wings or something with both hands, you could stay on that ladder conceivably. Not that you should, but you conceivably could. You can't do that here. You've always got to have all hands on deck on this ladder in order to stay there. So they say you should equip a fixed ladder with a ladder safety device. So that's what I've got on this page. If it's longer than 24 feet, you must, if it's 24 foot or longer, you must have a ladder safety device on it. So what is that? Well, this cage is one type of ladder safety device. Another thing could be a self-retracting lifeline, or another thing could be a vertical rail that locks, a vertical lifeline system of some sort, which I guess the self-retracting lifeline could be. But you need to be 100% tied off. The cage is really an old-fashioned thing, and it really isn't an acceptable ladder safety device anymore. But it's mentioned here because it's still on the books. But in best practice in the industry, you don't rely on these cages. Within seconds of falling, within a second or two of falling, actually, you'll be going too fast to grab a hold of anything on that cage. So, definition of a step ladder. It's a self-supporting ladder, right? Self-supporting ladder made with 2 sections that are hinged at the top. And beyond that, you've got to have the brace that you see halfway up, roughly, and it has to be fully opened. And then this particular ladder is set so you can climb up from both sides. But on that other ladder I was showing you, it doesn't. And the vast majority of ladders are not designed for you to climb the back end of it, ever. So this guy standing on the do not stand sticker at the top, you should never stand on that step or the black part. The top 2 rungs of the ladder you should never use to stand on. You can certainly grab hold of it with your hands, but you know, that's it. And this guy's in bare feet. We've seen this picture before, I think. He's wet up to his belly button, and he's dangling an AC-powered cord so you can use an AC-powered drill to drill with. But he is wearing his safety glasses. And then the fellow over here on the right, we saw him at the beginning on the title page. He's somehow trying to extend his step ladder. That's not allowed either. And you're never allowed to use a tool that's not in good repair. And a ladder is a tool, a piece of equipment. This one's missing a rung, so you should never use this ladder. You got to take it out of service. On the way up, you might be aware enough to see that. You're going to feel it maybe with your hands if you're going by and step beyond it. But on the way down, I guarantee you will forget. You won't be able to see it. And if you miss one rung on the way down, you're going down. You're going to go down without the ladder, or with it with you along the way, but it won't be pretty. So you need to take it out of service, do not use, or better yet, cut it into pieces so that nobody can use it. Climbing a ladder, you need to have 3-point contact. Again, that means at least 1 hand to grab the ladder, and 2 feet, or 2 hands and 1 foot. But you've got to keep hanging on, all hands on deck. That means you can't carry anything in your hands at all, because otherwise you can't do the 3-point contact technique. So here's some ladder review here. Ladder setback has to be 1 foot for every 4 feet of length. So that's that 4-to-1 ratio here. So if it's a 16-foot ladder, that means pulling it back 4 feet. And then you can see the next point here. The next bullet is on the top of that picture. It says the ladder should extend 3 feet above the upper support point. So whether that's a roof or another floor on the building, or the scaffolding that you're climbing up to. And then the last point, bullet point here, is actually just two things here. It says, do not stand above the fourth rung from the top of an extension ladder or straight ladder. So the fourth rung in this picture is 1, 2, 3 that you can see, and the one that you can't see is just below the deck up there at the top, and that's the last one you can stand on. If you stand on the third rung, it means you don't have 3 feet to hang on to on that ladder, but it also means you're creating, in this case, a teeter-totter effect where you could be possibly lifting up the bottom of that ladder off the ground as you teeter in there, possibly. And the second part of that last bullet down there is saying you do not stand above the second step from the top of the step ladder. So the top 2 rungs of the step ladder or steps are off limits for standing on. Okay, so summary, there's a potential electrocution hazard when using ladders and scaffolding. Well, the ladders, especially when they're made of aluminum or any other metal, there can be rungs on a fixed ladder that are made of metal too. And then most scaffolding is made of metal. Ladder setback has to be 1 foot for every 4 feet of length to the upper support point. So that's that 4-to-1 ratio I keep talking about. 4 foot rise to a 1 foot run. So the vertical number is the 4. And that's the way rise-run relationships normally are listed. So that's why I listed this ratio that way. The next bullet, a ladder should extend 3 feet above the upper support point. Okay, I just said that on the earlier page, all of this. Do not stand above the 4th rung from the top of an extension ladder or the 2nd step from the top of a step ladder. Next page, the overlap for a 32-foot extension ladder should be how much? At least 3 feet. Okay, so you can see a question like that on a test near you. Hint, hint. Next bullet, step ladders are self-supporting ladders made, or made, I should say made, of 2 sections hinged at the top. Third bullet here, fixed ladders are a permanent part of a structure and cannot be easily removed. Okay, so I had that in the presentation. I didn't mention it here, so it's important. I'm trying to catch things that I might have missed, so that's one of them. So watch that one, how that could be turned into a test question. The last bullet on this page, fixed ladders must be equipped with a safety device. If a ladder safety device, if the total length of climb exceeds 24 feet. So these are numbers. You either know the number or you don't. So watch any possible test questions with numbers like this. So remember the 24 feet related to fixed ladders. The fixed ladders are the vertical ladders that are mounted to a tank or the side of a building in some way. And the last page, I just got a few things here. It says the top rail of scaffolding should be at least 42 inches high. It kind of comes back to remind you that when we're talking about stair rails too, although the stair rail number is measured from the bottom if you're going up the ladder where your toes touch at the back, if you measure up from there, and so it's only about 36 inches when you're measuring from the tip. So those numbers will change on steps depending where you're measuring from. The second bullet, fall protection such as guardrails, they're required on scaffolding more than 10 feet high. Okay, that really comes to the next section. And also related to scaffolding, it's unsafe to interchange scaffolding parts from different manufacturers. So both of those points particularly should be on, well, all the things on this page really should be on the next section dealing with scaffolding, but you're just getting a precursor of it. Stick a fork in it and call this section done.